Yeah.
So, okay, I hope everyone online can hear me and people here as well. Welcome everyone to the fourth, if I'm not third seminar in our CDR Spring Seminar series. Thank you for joining us today, and a special thanks to you for agreeing to be the speaker. So you is a research fellow at the Institute for Transport Studies at the University of Leeds here. His research topics focus on the field of transport studies, unsurprisingly perhaps, ranging from sustainable urban transportation, transportation decarbonization, and behavior in general in experiment economics applied to transportation, obviously. So you currently is working on leveraging emerging data sources, such as virtual reality, psychology, physiological data, smart car data, on all this sort of new sources of information to more effectively model travel behavior. And the idea is to apply all this in an effort to decarbonize transportation, which is a massive source of carbon gases. So today we're going to hear from you about how to use SBR to study this. So thank you very much for joining us today, and the floor is yours.
Thank you, David. Thank you very much for the introduction, and I really appreciate for the opportunity to have this opportunity to show the works here. Today, I would like to give a case study of using virtual reality experiment tool to test the behavior interventions and understand the decision-making process of travelers in the context of switching from traditional high carbon emission travel mode to greener travel mode. Today, I will tell the setup of the experiment, the types of nudge we use, and the results, and tell us how we can use virtual reality as the experiment tool in such kind of behavior experiment. And first, when we talk about the carbon emission net zero in transportation field, the government, the industry, the academy, and the social public should work together. For the government and the industries, they implement new policies, they make new investments and apply new techniques to make the travel mode greener and less carbon emitted. For example, the Leeds government cooperate with First Bus and update the traditional fuel bus to electric bus last year. But then, most importantly, we should consider whether these changes, the new policies, investment techniques, will lead to the social public change their traditional travel patterns to a greener one. And this is what we concerns. We are interested in what kind of interventions can we design and how this treatment works in guiding the behavior of the public. In the literature trend of guiding the behavior of travelers from high carbon emission mode to low carbon emission mode, the researchers have widely discussed using behavior interventions to persuade the travelers shift their behavior. And these strategies are usually called transportation demand management. Traditionally, these kind of strategies are hard measures. For example, altering the physical environment. For example, building the new transportation infrastructures, update the bicycle lanes to persuade travelers using more bikes. And another kinds of these hard measures are some legal or economic policies. For example, congestion charging. However, this kind of hard measures usually cost a lot, both in the time, money, and also some political cost. For example, this kind of compulsory policies may cause oppositions from the social public. The government and the researchers are thinking more and more how to use some softer measures to change the perceptions, beliefs, norms, and attitudes of travelers, and in this kind of softer way, get the choosing greener travel mode. When we talk about testing this kind of new travel demand management, traditionally we usually use two kinds of experiment. First, we rely a lot on this kind of stated preference choice experiment. We will list the choice alternatives and their attributes, and the participants can make choice based on the attribute trade-off. The advantage of this kind of behavior design is that the researcher can set up a large set of hypothetical choice scenarios in a relative low cost. But the disadvantage is also obvious. This kind of stated preference choice experiment always lack of actual consequence. The participants just state what is their preference. And this lead to the noise and the biases in stated report behavior. To overcome these limitations, there are another trend of experiment method which rely on the revealed preference choice experiment, including field experiment, lab experiment, and some travel diary collection experiment. The advantage of this kind of experiment is that the participants will make real behavior decision choice in the experiment environment. So their choices will lead to the real outcomes. For example, the real time cost, the real money cost. So this kind of experiment is incentive compatibility, and it can better reflect the preference of the travelers. And through the random control, for example, a lot of RCT field experiment, the carrier effect of the treatment can be analyzed. However, there are also some disadvantages here. The transportation decision-making environment is usually very complex. Different weather can influence your choice, different travel mode attributes, the price, the waiting time can all influence the decision significantly. But in real world, it's relatively hard to control these things. For example, in the randomized controlled trial experiment, we usually can only control the social demographic and the travel attribute characteristics of the participants. And for the field experiment, it's relatively expensive to recruit participants and launch different interventions. And because of the flexibility limitation of the real world, sometimes we can only design some relative simple interventions, but cannot break our imagination and design some more interesting interventions. And another thing is that when we collect the data in real world, we usually can only observe the outcome of the decision behavior. For example, we can only observe this participant choose bus today, but we don't know their potential unobserved choice set. We don't know if the participants make the bus choice between, for example, between three alternatives, bus, taxi, and the car, and then finally he choose the bus. We can't observe this kind of choice set. So it's a little bit difficult to understand the trade-off process when we using this revealed preference choice experiment data. And not only transportation researchers, but the behavior researchers have tested different kinds of nudge in transportation field to test whether these incentives can change the behavior of the travelers. And most of these studies are field experiments. There are some research gaps here, as we discussed before, limited by the technical conditions and policy flexibility conditions. The design of nudge in transportation field is usually very simple. For example, most of the studies use message sending as a kind of reminder or using some social norm message to get the behavior of the travelers. And another limitation is that because usually this study only collect the outcome variable or the observed truthing mode, so they usually focus on the treatment effect analysis. However, the working or node mechanism of nudge is less explored. In the transportation field, we can see even for the same kind of nudge intervention based on the same theory. For example, the social norm theory, the effectiveness of the nudge varies a lot in different contexts. Sometimes it is effective, but sometimes it's not effective. But why this work or why this not work, this is less explored. And another limitation is that because of the lack of the unobserved choice size, the trade-off decision-making process is less modeled. So based on the above discussion, this study will lead us to think about how can we combine the advantage of both experiment method. For example, compared to stated preference stated preference choice data, how we can build a more realistic and experiment environment with a real outcome of the choice, and compared with the reviewed preference choice experiment, how can we design the experiment environment, design the treatment in a more flexible way, and collect more abundant and detailed data set. Today, I would like to introduce a potential method with the virtual reality experiment as the experiment tool to test the interventions in the context of travelers' travel decision making. The virtual reality offers a very good opportunity to immerse individuals in real scenarios and collect the abundant data set. For example, through the virtual reality equipment, we can build the driving scenario, cycling scenario, and even walking scenario. If you are interested in this kind of equipment and information, you can visit the website of Virtual City and the Center for Immersive Technology. Both institutes are from University of Leeds. And we cannot, when we're using the virtual reality techniques, we can not only collect the behavior data. The equipment offers us more opportunity to collect some different data set, which is very hard to collect in traditional experiment. For example, we can collect the EEG data, which describe how we brain behave during the decision-making behavior. We can also collect the eye tracking data. We can explore what the participants pay attention to during the decision-making. process. And similar, we can also collect some skin conductance data. It describes how your body how your body reflects to different treatment. For example, in different travel conditions, your stress level may be different. This is the first advantage of virtual reality. And the another advantage of virtual reality is that through the building process, you can break your imagination and build a world with more flexibility. For example, in the Nexus project, the researcher built some future travel mode. This is not possible to study in the real world, but it can become true in the virtual reality environment. For example, flying taxi, hyperloop, and self-driving taxi on road. Not only the travel scenarios can be shown in a very innovative way, and also the treatment itself can be designed in a more innovative and complex way. I will discuss this later. So based on what we discussed about, this study aims to answer the following research questions. First, from the policy perspective, what innovative nudge interventions can be used, especially compared with the traditional nudge message sending? What new things can be designed in the virtual reality environment? And what is the effectiveness of the nudge in guiding travelers towards a greener travel choice? And secondly, from the method perspective, how to test the nudge in a controlled and real virtual reality experiment conditions. And thirdly, about the decision-making modeling, what is the trade-off process of participants when considering choosing or shifting to a greener travel pattern? And how does nudge play a role in the learning process of the participants? Okay, based on this research question, we build a choice contact. In this choice contact, the participants are asked to make travel choice between two kinds of travel mode. The first is a high carbon emission travel mode. It is taxi in this study. And the second one is the public, it's a greener travel mode, which is bus in this study. And the videos showing on the screen is the record from the participant's view. After putting on the virtual reality helmet, the participants can move their head around and to see different degree of the scenarios. And this shows the steps and the framework of the experiment procedure. Before the before the start of the formal experiment, the participants can do a pre-experiment pilot to get familiar with these two kind of VR scenarios. They will experience the VR taxi trip and a VR bus trip one by one. This can help avoid variety-seeking behavior in the formal experiment, because some participants may change their choices during the experiment, not because of they are not satisfied with the previous choice, but they want to experience the another mode because of the curiosity. So before the formal experiment, we first ask them to experience these two trips. And then after the experience and double check the participants have no questions or any body issues, for example, feel dizzy or something, we will start the formal experiment. At the first step, the participants will make a stated preference choice between the bus and the taxi, and the both trips are described through three attributes: time, cost, and carbon emission. This information board will be showing through the virtual reality helmet, and the participants can make their choice through a controller. You can imagine this step when just like in real world, when we would like to make a travel schedule, we will check the travel information through the Google Map or similar travel planning app to get the information and then make some trade-off and then make our choice. After making the travel mode choice, the participants will experience the chosen mode through the VR scenario. And the attributes of the VR scenario is related to the attributes shown in the timetable, in the information table in the first step. And after the experience, after the experience, the participants have a chance to revise their initial choice. For example, they make the taxi choice for the initial choice, and after experiencing the taxi, they can choose to revise their choice to bus or insist to the initial choice, the taxi. And at the first step, we will, in some treatment conditions, the participants may get intervention by the nudge pre-trip. And during the VR experience, in some conditions, the participants may get affected by the nudge in-route and post-trip. I will introduce the details of the treatment design in the following slides. And for each participant, there are 6 choice tasks. They will make the repeated tasks one by one, and after the 6th choice task, there was a post survey asking about the social demographic and their daily travel patterns, and also the participants were asked to state their green attitude through a Likert 5 scale. And to make our design incentive compatibility and avoid the virtual reality scenario spend too much time making the participants feel really tired. 1 minute in the information, 1 minute in the information board equal to 10 seconds in the virtual reality scenario. And about the monetary cost, at the beginning of the experiment, the participant get a fair budget to spend as travel costs and a fixed £10 for the appearance fee. And after the participant finish all the 6 tasks, we ask the participants to roll a die twice. And based on the results of the rolling, the travel cost will be calculated. And the rule is that the first roll will be related to which task is selected to calculate the travel cost. And the second row, if it's odd, half of the real cost of the initial choice mode will be deducted from the £5 budget. If the number is even, half of the real cost of the revised mode will be deducted from the £5 budget. For example, a participant row 3 for the first time, and then the third task will be chosen. And the second time, the participant rolled 4. It's an even number, so the revised choice cost will be deducted from the £5 budget. In other words, through this rule, each choice the participant made during the experiment will have an equal possibility influence the final reward of the participants. Yeah.
And it is a random selection of whatever series of choices, and randomly select one of those choices. That choice is used to determine what their final participation.
Yes, the £10 is a fixed appearance fee, and the £5 is endorsement. Yes, yeah, that is one possibility. If they always choose the cheapest one, for example, they always choose the bus, they will always experience the longest travel time in the virtual reality. So that is a trade-off. Yeah, they can pay money to they can pay money to buy time. Yeah, in this context. Mm. Yes. 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 I will have some more explanation here. For example, in this context, for the bus travel, it include 22 minutes in vehicle and 15 time picking up. And for the taxi, it's 22 minutes in vehicle and 2 minutes picking up. So if they choose bus, they will experience a longer time compared to the chosen of taxi in the virtual reality environment.
Just for people.
Thank you. Just wondering, is it the cost of time that you're capturing, as opposed to the people's cost of their own time, as opposed to the disutility experience or the utility disutility experience from these specific choices? Because the choices themselves, okay, it seems to vary in time.
Yes, the utility vary in time, cost, and in all of these three variables.
Okay, thank you.
Yeah.
May I ask about the role of carbon? Because you mentioned a lot about the time. And how about carbon? Because it's like
in our study, the bus always have lower carbon emissions than the taxi, and it's described as
but it influence human behavior, because when you're talking about the issue, and then you talk about, because they will need to spend a lot of time on bus, so probably they will choose, there will be a trade-off of they choose bus with low cost, but you did not mention about carbon. It's like, you put in there, but what's the critical role of it? If we decide we choose bus based on cost and time. Sorry.
Yeah, actually the carbon emission will not have a direct influence on the reward or the experience. It's just showing the environment impact of this mode to the individual. But whether they care about this is a question, and I will show the results in the later slides.
Longer there, just because it's a true virtual reality experiment. If I was doing this and somebody offered me a chance to spend 40 minutes in a virtual reality experiment versus 32 2 minutes. I'm taking the 40 minutes, even though it's a bus as opposed to a taxi. See what I mean? It's that in this experiment, individuals are choosing, the time varies. So the virtual reality experiment is going to be quite unique and cool to people. So they have a choice here, spending 40 minutes in a virtual reality environment versus 24 minutes in a virtual reality environment.
It's like the feel VR is really cool, so they want to stay longer, but it's not that they want to bring their own.
That is also a potential see. What we did in the pre-experiment is we would like to avoid this kind of thing, because we want to at the first step, we want the participants to get familiar with these two kind of trick and then make their choices in the following formal context based on the attribute trade-off. But it's also a potential influence, because the participants really enjoy wearing the helmet and doing the bus travel. But at least no participants during the experiment report this kind of thing to me. Yeah, but maybe yeah, thank you.
You said you will let the participant to get familiar with the VR, but I have tried VR experiment before, and I feel after wearing the helmet for like after 5 or 10 minutes, I will feel quite dizzy.
Yeah.
So if they choose the first, they will feel the cool, but if they feel uncomfortable, can they stop or they choose another one option? Do they give their choice?
Yes, this is also possible. Actually, the participants will make 6 choice tasks one by one. And if they feel dizzy, they may choose taxi in the following choice task, because the taxi usually takes shorter time and they can spend less time in the virtual reality scenario. And this is also one of our research questions, but not in this study. We will use the skin conductance data collected during the experiment to measure their stress level and the tiredness level to see if this body indicator will influence the choices. But in this study, we incorporate all the influence in the time, because we think that the longer time is a kind of cost. It also influences the time cost you spend and also the discomfortable you feel, and all of this in the time contributes.
Thank you.
In regard to someone talking about considering the carbon, one reason that might work as an aspect in the choice is that people might get warm glow from feeling they did the good thing. So it's not necessarily not considered. So that might be a good thing. I think the money thing might be reduced as any sort of incentive by the random nature of the dice throwing, because people are okay with dice throwing affecting the payoff on a single task, but when they're going to be decided depending on multiple choices, that's less likely, I would think, to incentivize. Just a thought.
Thank you. And I will show the treatment design later. That is how we highlight the carbon emission related.
Sorry, we have one question from the audience online. So Tom wanted to ask. Let's try to hear him here.
Thank you, and forgive me for butting in.
Tom,
yeah, hopefully you can hear me. I realize a lot of people are fascinated by the methodological aspects of this, but I'm really keen to get to the findings. So would you be allowed just to get through his slides, and then there might be time for questions of all kinds after that?
Thank you again. Yeah. I will continue the about the treatment design. We designed three kind of notch based on the timing of the notch to highlight the carbon related thing. Yeah. The first is the notch pre-trip. At the first step, when the information board is shown to the participant, in the control condition, for the taxi, it only shows the total monetary cost of the taxi. But in the treatment condition, the monetary cost is divided into two parts, a fare cost and a carbon tax. And the total amount is equal to the control condition. So these two choices won't influence the final reward outcome, but only the salience of the carbon tax make a sense. Through this kind of salience, we would like to show the environment-related impact in a more prominent way and influence the decision-making at the very first. And the second thing is the notch in-road. If the participants choose to make a taxi travel, at the beginning, there will be a poster at the opposite of the street. In the control condition, there will be a irrelevant poster. It's a GP online service poster. And in the treatment conditions, there will be a carbon emission related poster, which said reduce carbon emissions, save our children's future. Through this poster, we would like to call the participants to think more about their responsibilities and the impact of carbon emission on the future generations, and also call their social norms. And for the notch in route, we have another element, which is a carbon emission meter. In this treatment, in the taxi vehicle, there will be a lock on the vehicle, and in the control condition, there will be only the time and an irrelevant label. But in the treatment decision, there will be a carbon emission meter showing the carbon emission accumulation of this trip. It changes in time, and there will be also a leaf. The color will change from green to yellow and then to red at 1,000 and 2,000 gram carbon threshold. And through this kind of design, we would like to remind the participants to pay attention to the energy consumption in time, and always think about the environment influence of their behavior. And the final treatment is a notch post-trip. After the trip, there will be a taxi receipt shown to the participant. In the control condition, there will only be a traditional taxi receipt with showing the travel time of the trip and the total fare of the trip, and also a irrelevant label. But in the treatment condition, we not only show the travel time, the total fare, but we also shows the carbon emission of the trip, and also a smile face or sad face here. Through this reflective learning message, we would like to encourage the participants to think more about their past behavior and the consequence, and change their behavior in the following choices. To see how this intervention works, you may scan this QR code to see the video recording of the intervention videos. I think I can share these slides after the, yeah, okay, yeah. And about the treatment design for each participant, they will make 6 choices one by one. It should be noted that considering the sample size limitation of virtual reality experiments, there is some difficulty in recruiting people and spend a lot of time collecting the data. This study didn't employ a random control trial design to analyze the carrier effect of the treatment. Instead, we utilized an approach focusing on the choices of participants across a series of well-controlled choice scenarios. This approach allows us to observe the impact of each intervention by modeling the effects of different nudges on the choice probabilities. And this design can also help us to learn, to analyze the potential learning process of the participants. Therefore, we in the experiment design for different groups, we increase the participants would receive a increasing amount of interventions from the first task to the 6th task, and there were no interventions for the first 2 tasks, and the nudge post-trip only exists in the last 2 choice tasks. We have 4 different group designs here. And for the data collection and the sample composition, we collected the data in Virtual City, University of Leeds, and a pilot was launched in February 2024. Based on the results of the pilot, we adjusted the experiment parameters and the timeline of the experiment. And the formal experiment launched from March to May last year. Through email and poster, we recruited the participants most from the students and the staff of the University of Leeds, and 130 registered, and finally 105 showed up. These 100 people completed in total 630 tasks and 1,260 choice observations. And finally, they get an average 12.4 reward. Here is the descriptive analysis of the results. So x-axis, the different bar means different tasks with different combination of the nudges. These 3 numbers, 100, for example, means whether there is nudge pre-trip, in-route, and post-trip in this task condition. We can see in the green frame, the conditions with nudge interventions compared with the conditions without nudge interventions. The proportion of shifting from taxi to bus is here, the green part, and the proportion of shifting from bus to taxi is lower. And based on that result, we continue to see among the tasks where the initial choice is taxi, how much shifted to bus at the reversed choice. And the greener the color, the higher the proportion. we can see compared with the conditions without nudge, the other nudge conditions, the proportion of shifting behavior is much higher. And about the modeling, we utilized the discrete choice model to model the whole dynamic decision-making process. I will have a very brief introduction of the discrete choice model. It's a kind of model based on utility theory. Traditionally, we use the random maximized utility. For individual n, we'll make a choice among g alternatives, and the choice will be the alternatives are characterized by the utility function, where there is a deterministic part utility and a random utility part, and the utility is influenced by beta, which is the preference, which is a vector of taste towards different attributes. And for the choice part, the participants will make a choice based on the utility analysis, and the probability of choosing a specific alternative will increase with the increase of the utility. And this kind of model is usually good at exploring the trade-off behavior. For example, there is a better attribute and a worse attribute. The money cost is higher than the bus for the taxi, but the time is much lower. There is a trade-off between this, and this will be reflected to the chosen probability. So based on the principle of the discrete choice model, let's revisit the decision-making process of the participants during the experiment. Within each task, the utility of the initial choice is reflected by initial choice. You can treat the utility as a latent variable and the observed choice as the indicator of the utility. First, the utility of the initial choice is influenced by the travel mode attribute, cost, time, and carbon emission. And then it may be influenced by the attitude of the participants towards some green behaviors. And for the initial choice, it is also influenced by the nudge pre-trip. And then we assume that the nudge the participants experienced in previous tasks may have a lasting effect. We call it a residual effect. And the nudge pre-trip accumulation and nudge in-road accumulation means how many times the participants have experienced before this task. And it is also influenced by the order of the task. And then considering the revised choice, first, the utility of the revised choice is influenced by the choice of the first task through a stickiness parameter delta, and the systematic utility of the initial choice and scaled by a scale parameter mu. And also for the reversed choice, it can be influenced by the nudge in-road and nudge post-trip the participants experienced during the VR scenario. And this is only one task. And considering the potential influence between tasks, we think that the choices from the previous task may have a lasting learning effect on the next task's choice. And this task may be moderated by the experience of the nudge received in previous task. This is the whole process, and we construct a dynamic model, including 12 sub-models to model the 12 choices from the 6 tasks. And this is the equations. I don't think I have the time to introduce the details. But one thing we need to know is that for each task, we have a utility function for the taxi and a utility function for the bus. And the different attributes influence the equations of each utility function accordingly. This is for the initial choice, this is for the revised choice. And this shows the probability function for the choices. And we use maximum likelihood estimation to do the estimation. And here shows the results. Let's first see how the attributes influence the initial choice. We can see the cost and time have a negative and significant influence on the initial choice. We use the log cost here to control the non-linear effect here. So the parameter is much larger than the other. But the carbon emission don't have influence on the utility. It's not significant. And then green attitude is added on the utility of the bus travel. And the results show that the participants with higher attitudes towards greener behavior, with more positive attitude, they will be more likely to choose bus. And for the nudge trip, it is not significant here. But for the experience of previous nudge, we can see the more times the participants experience the nudge pre-trip in previous interventions, there is a positive influence on choosing taxi. We think this is a kind of crowd out effect, because the participants may think, I have paid the tax, so it's fair for me to choose the taxi. So it has an opposite influence. And for the nudge in route, the more time it experienced the nudge in route in previous work, the less likely they choose the taxi. They are more likely to choose bus. There is no nudge post-trip accumulation here, because the nudge post-trip only exists in the last 2 tasks. And for the when we consider the revised choice, first, the stickiness parameter is positive and larger than 1, which means the people would like to stick to their initial choice within a task. And the scale parameter is less than 1 and significant, which means when considering the revised choice, the participant will pay less attention to the trade-off process compared with the first initial choice process making. And for the nudge in route and nudge post-trip, both of them have negative and significant impact on the choosing of on the probability of choosing taxi, which means both of these nudges works in persuading the participants less choosing the high carbon emission mode. And then let's see how previous choice influence the following choice tasks. Firstly, the learning effect gamma is positive and significant, which means which have a similar explanation as the stickiness parameter within a task, which means people would like to stick to their previous choices. However, if they experience the large post-trip in the previous trip. This kind of lowering effect will be moderated, and the post-trip will reduce this kind of stickiness, which means after experience the post-trip notch, the participants would like to change their habitual behavior in the following tasks. So in conclusion, participants pay less attention to the variable carbon emission, but the nudge interventions can help them pay more attention to their environment-related choice. So pre-trip is not working in this case study, and it even can exist a crowding out effect. But for the injured and post-trip, they are both works. And there are potential lasting effects during the dynamic learning process. For the injured, there is potential rescue effect. The experience of previous injured trips will have some lasting effect on the following choices, and the post-trip will have a moderating effect on the stickiness behavior. So inclusion, virtual reality is a very promising experiment tool to help us do some very flexible experiment and very complex intervention under a well-controlled condition. It compared with traditional experiment method, it enhanced the realism and makes a behavior, makes a experiment a symptom compatibility one. And it also can help collect the more detailed data and get deeper insight into how decision makers making the trade-off decision between different choice alternatives. However, there are also a lot of challenges when we using virtual reality experiment. First, as mentioned before, limited by the recruitment difficulty and time cost, it usually have a relative small sample size. This small sample size can limit the treatment design. For example, we can't have so many RCT groups and maybe relative harder to explore the Carroll effect here because the explanatory power is relatively lower if the sample size is small. And when we build the scenarios and coding the interventions, it maybe cost some money and time to rebuild a new scenario. But luckily in this experiment, we reuse some scenarios and some coding from other from previous project. It saves us a lot of money and time. Maybe in the future there can be some more platform to share the elements of this kind of experiment elements to help build this kind of experiment easier. And the last one is that although it's more realistic compared with some stated preference experiment, it's not the 100% real experiment. So we still need to think about if this treatment will be scaled up to the real world, will they have the same findings and the treatment effects as we found in the virtual reality experiment. But I have to say, although it's not 100% real, the findings from this kind of virtual reality experiment can have a good implication and guidance to the researchers and policymakers to design their policies before implementing in the real world. And thank you. That's all what I would like to see. And thanks to the co-authors, Dr. Thomas Hancock and Professor Krisma Chaudhary from University of Leeds ITS. And thanks to Dr. Albert and George, they are from the virtual city, and Professor Oliver Hauser and Professor Yatsan. This work is under the Nexus project. The PI is Professor Krisma. And in this project, we aim to using some innovative method collecting way and some multiple source of data to build some next generation behavior decision-making models. For example, we use virtual reality to immerse the future travel mode, air taxi, hyperloop, and we also interested in incorporating physiological data into the decision models. For example, the EEG data and the skin conductance data. For more information, you can visit the website. And thank you. That's all. Any comments and questions? Thank you very much.
Thank you very much, you. I know we're over time, so I understand if anyone needs to move. But if you want to stay and discuss a little bit, happy to stay here. Also, you mentioned you were happy to share the slides. So if anyone wants the slides, let me know or you, and we can send you the slides. Any questions here in the room? No?
For building a VR scenario, how easy or how difficult for researchers? Is that like a programming language based, or you need to do that by those professionals, like a video?
Yes, for building the scenario, we have a simulator software developer using the 3D Unity to build the scenario. So I'm not sure the level of the difficulty for a researcher from other field to build these scenarios themselves.
Is that something like a function, like for person, then you get a person object, and the function for taxi, you get a taxi object, or you need to do some like arts those based work for the whole video?
There are different elements. Yes, for example, for the taxi, there is a module of the taxi, and you can add the taxi module into your VR scenario.
Okay.
It's not like a video.
Okay.
It will create the scenario in time during the experiment.
I see. I see. Okay, thank you.
Thank you. I really enjoyed that. If you ever need any volunteers to take part in one of these experiments, let me know, because I'd love to try it out just to see what it's like. Just maybe a comment as opposed to a question. You pointed out the sample size, and so you're on top of that. But just to flag, you're looking at their in effect interaction effects. So you could be grossly underpowered, and it means that just some of the effects could be the exact opposite of what you're finding. And I know there was some interpretation of some results, but perhaps another plausible explanation may be just that the sample size issue. So just think about that. I guess as the project is ongoing, you can add more observations, and you can kind of see what's going on, which will be really interesting. Just one other comment in relation to the choice tasks itself. It's really cool that it's in a virtual environment, but I wonder, is the same limitation in terms of social desirability bias, for example, that you would have observable in a stated choice task when it comes to normative attributes, be also evident here? Even though one could argue that it should be equally distributed across choice tasks, but the nudges itself, it kind of seems that maybe they're kind of motivating people to actually feel, okay, this is what the researcher wants me to consider and do. So it's that social desirability hypothetical bias aspect, I suppose, is just something to think about.
Yeah, thank you for your suggestion. Yes, we try to avoid this kind of wholesome effect during the experiment. We don't want the participant to feel to guess out what is our research purpose and behave like what we want them to choose. So we for each participant we always have the proctor to have the same sentence for them at each step, and to avoid too much emotion interactions with the participants. And we also package this package this experiment as a travel choice experiment, and we don't mention the for example the green travel related thing, to avoid they will always choose the greener mode. Thank you very much for your comments.
Okay, so I think given time, we're going to close here. Thank you very much, there are a lot of comments here. I will give you access to the comments on the chat as well.
Yeah.
Thank you very much. And as I mentioned before, you're welcome to attend next week at the same time, a new seminar about food waste. So thank you very much, and hopefully see you next week. Cheers.